Hello everyone, welcome to ML with AP. This is the third video of the series of video where we are discussing decision tree, and we have learned both the classification and regression supervised learning use cases with respect to decision tree. Now this is in the first two videos we have clearly seen how decision trees are made, how decision tree classification is done, what is entropy, what is information gain, how decision tree regressor works. In this particular case, what we are going to do is we are going to learn how to code it. Okay, so without further ado, let's see how to code it. Let's jump to our Jupyter notebook and code it. Okay, so this is my Jupyter notebook, friends. Okay, what I'm doing over here is I will try to give you a step-by-step details of how we can configure and code a decision tree in using SciKit-Learn Python package, and we can get the predictions done on both for the classification and regression settings. It's very similar. Okay, so for this what we are doing is, let's take it step by step. We are importing the pandas and numpy basic packages. We are also importing the SciKit-Learn or SciKit-Learn has inbuilt data sets, right? So it has a very famous data set, iris data set. Everybody knows about it. We'll load this iris data set from SciKit-Learn and we'll do decision tree based on that. Okay, now here we are loading the iris data set. We are importing it into a data frame. Okay, what we are doing is we are creating a separate df species column in the data frame, and what we are importing, we are getting the data.target from there. So data.data has my x and data.target has my y variables, right? So over here again I'm doing all this to get the data over here, right? And if you notice, let me show this thing. Okay, let me run this. If I see my data frame over here, I was just trying to talk to you that why we are doing this, if you notice, right? So initially the data, the species or the outputs are given as 0, 1, 2 or numerical variable, right? We are just replacing that with target names, and target names are the actual names like Setosa and Virginica and versicolor, right? There are 3 categories under my output features, right? Output y variable, sorry. So what we are doing is over here we are replacing 0, 1, 2 with Setosa, versicolor and Virginica. That's all we are doing. Let's print our data frame. Okay, so the data frame, my species has come nicely. My data frame is ready. What I will do is the last column is species. I'm taking into a y, my predicted y variable. In my x, I'm dropping the species. So my sepal length, sepal width, petal length, petal width will become my x figure. Okay. Again, over here, I'm storing the column names and the labels into feature names and labels, which I'll later use. Okay. Now, to represent this, I could have done this with 4 features. What I'm doing this over here is I'm only limiting it to 2 features, so that with 4 features, it's very difficult to see it into a 2-dimensional figure, right? So my visualization will not come great. So what I'm doing is I'm using only sepal length and sepal width out of this. Out of 4 features, I'm using only the first 2 features. How we are doing it? So if you know pandas, then I'm filtering all the rows and only 0 and first column, right? Over here. So my x now became 0, 0 and first 0th and first column, which is these 2 columns, sepal length and all the observations, right? And after that, what I will do is I will do it again from SciKit-Learn model selection. I'm doing a trend test split, which is pretty standard. My test size is 40%. Random seed for reproducibility I have given, and I'm getting it into x train test y, test x, y train test y, right? Let me run that again. Now I'm getting the from SciKit-Learn tree decision tree classifier. So I will instantiate, but before that, let's check the shape of like x train and y train are good or not. X train is 92, so 90 observations, 2 features as I was saying. Test underscore x, 60 observations, y train 90. Again, this is a column vector. Test y column vector 60 observations. Perfect. Now what I will do is I will create my classifier model CLF which is decision tree classifier. What I'm specifying over here, I'm specifying few of the features, right, which it needs. That what is the maximum depth of the tree I want to calculate, right? Let's see that what are the other parameters which I can pass. Over here, if you notice that there is something called criterion, which is Gini by default. So on the right hand side, which you see is the default ones, right? So there are many features which you can send over here, right, which you can pass, and based on that, so these will become your hyperparameters, right? These are the things which you can tune. Okay, so maximum depth is none. If you provide none, then it will keep further subdividing, right? Okay, so maximum depth I have given 3. Random state I have given 42. My criterion will be Gini. Now Gini is something which I have not discussed. I was only discussing the entropy, but let me quickly discuss the Gini also, and maybe I will go back to my spreadsheet, and somewhere I have mentioned over here what is Gini. Yeah, if you see, this is the way I was calculating the entropy. Gini is very similar. It's just the formula is changing. Okay, so what the formula is changing, instead of this, in case of binary classification, my Gini over here, yeah, this is the entropy formula, right? In case of binary classification, it will split into C is equal to 2, so it will split into 2 parts. Similarly, Gini is nothing but, in case of binary, it will be 2. So my positive class square, negative class square, and 1 minus. This is what Gini is, right? So Gini is another way of measuring the impurity, right? This is called Gini impurity. Entropy was one way of measuring impurity. Gini is another way of measuring impurity. And Gini is considered better. One of the main reasons why Gini is considered better is because over here, the log is actually a more expensive calculation. Square is a less computationally intensive calculation, right? So it's easier to calculate with a computer, while log is a harder calculation, right? And as you know that you have to, every subtree, every candidate branch, you have to do multiple times these calculations. Gini performs better in that. It is faster with that respect. Okay, so the default, as I was seeing over here, if you see, this is Gini. Okay, if later you over here, let me show you. Yeah, criterion, right? So Gini is one of the criterion, entropy and log loss. It provides, so my SciKit-Learn package provides criterion as Gini, entropy and log loss. By default, it takes Gini, but we can mention entropy also over here. And we have already seen in our previous videos how entropy is calculated. But now we know that Gini is also how to create 1 minus the positive class square minus negative class square, right? That's all it is, right? And that's another way of calculating the impurity. Okay, now let's move on what we are doing. Okay, so again over here, what I'm trying to do is, we have already built this my classification model, right? And I did a fit. I did a fit on what? X train, Y train, because I got X train, Y train, 1990 observations. I did a fit. My model CLF.fit is already, the fitting is done. Now what I need to do? I need to do prediction. But before that, let's see that how my model is performing, right? Okay, so for that, what I'm doing is, SciKit-Learn also provides decision boundary display. So I can display the decision boundary. When I did a fit with the maximum depth as 3, okay, this particular SciKit-Learn provides a graphical interface where you can see, or UI, where you can see that how the split has happened, right? So if you notice the split over here with maximum depth as 3, and based on 2 criteria, that's why I've taken 2 features, because it's much more easier to visualize everything in 2 features, sepal width and sepal length. If you notice, this is more purer, right? So the entropy is very less over here, right? But there are a lot of misclassifications which are happening, right, over here in these regions. Okay, so this is one observation which is come. Let's see that what is my prediction. Okay, so I'll do CLF.predict on test X. Okay, so what will be my prediction? Okay, Now what over here I am doing, if friends, if you know what is a confusion matrix, this is a 3-class problem, right? So I have 3 classes in my output. So my confusion matrix will become 3 cross 3, right? Correct? Over here, I'm not doing anything. I'm just printing out my confusion matrix. My confusion matrix will be 3 cross 3 because I have 3 classes, Setosa, versicolor, and Virginica. And similarly, the true label confusion matrix is nothing but the predicted versus true. Over here, if you notice this closely, you'll notice that this model didn't had lot of problem in identifying Setosa from versicolor and Virginica, right? See, it is 0, 0 and 1, 0. So true positive, true negative, false positive, false negative, right? This is how you read. But between versicolor and Virginica, there is a lot of confusion which is happening, right? The numbers are higher. This is true positive, true negatives. These are higher. But there are a lot of misclassifications also which are happening, 6 and 5, right? And that is also being shown over here. Setosa is more or less cleaner, low entropy. But between Virginica and versicolor, there are a lot of misclassifications which are happening, right? Which is being represented over here in this confusion matrix. Okay? So the predicted and true label. This is how the confusion matrix. Let's see the accuracy for that. Accuracy is almost like 80% for this, which is due to all these false negatives and false positives, right? Okay. Now, accuracy is one of the marker of classification, one of the performance measures. There are others, if you already know. There is recall, there is precision, there is F1 square. All these things you can calculate after the model is fit and the model is prediction is done, right? You can calculate. So I'm calculating my precision, I'm calculating my recall. Okay, and if you want to know about precision recall, I think I have uploaded a video already on what is precision, what is recall, what is accuracy, what is ROC, AUC, everything I have already uploaded. So please go ahead and watch that. Of course, you can print, if you can print everything in one go itself with this command, right? So if you matrix.classification report, if you publish, then it will give you everything. Now, if you notice the Setosa, the precision is very good, 1, right? But between versicolor and Virginica, if you see, it is lowering down. So there was confusion between, for the model to identify between versicolor and Virginica. Okay. Now, as in one of the last video, I also mentioned that this is decision tree can also be used to extract importance of the features, right? How important the features are, and the way to do that is to calculate the importance of the feature, right? And if you notice, I have only 2 features, sepal length and sepal width, but between them, 71% of my prediction can be done based on the sepal length itself. So that I will regard as a more important feature, right, than sepal width. Okay. The last thing which we are going to do is, now there are many hyperparameters which you have seen, right? So the criterion was one, depth was one. There are various others also. How do we arrive in a very methodical way that what is the right hyperparameter? So the grid search CV is commonly used in SciKit-Learn to arrive at the, or to search the feature space to arrive at the right set of hyperparameter. For that, what you have to do is first you have to create the feature space, right? Or your hyperparameter space. So in hyperparameter, what I'm trying to do is, my criterion is Gini or entropy, and my max depth is all these numbers. Now I'm telling the grid search CV that go ahead and calculate the combination of between Gini and entropy for which my precision, this is the scoring, one of my performance measure is highest, right? So what grid search CV takes it? Grid search CV takes my tree params, right? The space, right? The hyperparameter is search space. This is my hyperparameter search space. So criterion can be either Gini or entropy, max length can be all. And for all these combinations, you find me the best one, right? That's what grid search CV is. It also takes into the classifier, right? So my tree classifier, it is taking the classifier name, it is taking the hyperparameter search space, cross validation, how many times it will do the, so every my whole observations or the number of observations will be split into 5. Okay, 5. By cross validation set 5, it means that it will be split into 5. For 4 will be used for testing, 1 will be used for 4 will be used for training the model, and 5th one will be used for testing the model. And what we'll get is the average of it, right? So in the first case, let's say my first block or first 20% record is treated as testing, the rest 80% is treated as training. Similarly, between 20 to 40 will be treated as testing, the rest 80% will be treated as training, right? Similarly, this is done so that if suppose my data is highly skewed, right, then if I am taking the first 20% or bottom 20%, it will not give me an accurate result. So that's the whole point of cross validation. It's an entirely different area. Maybe I'll make a video on this grid search CV also at that time, and we'll see. Okay, now it also accepts something called a scoring. Like you are asking grid search CV to say that you maximize this on this feature space, but based on what criteria, what should be maximized? So my scoring, I'm providing it as precision over here, but you can provide other things also, like whatever this grid search CV or this decision tree classifier understands as a scoring mechanism, which is precision, recall, accuracy, F1. You can mention any of these, right? And then you run this. And what it will give output? It will give from the feature space, hyperparameter space, it will give you that it is telling me for Gini and max depth at 4, your precision is highest at that level. Out of all these combinations, when the criterion is Gini and max depth is 4, that's where your precision is getting highest. So that's the value which you should select. And that's the whole purpose of using grid search CV, to get or to tune the hyperparameter of a decision tree. Okay. So friends, I hope you understood how we write our code with using SciKit-Learn for our decision tree classifier. We can do very similar thing with decision tree regressor also. It's exactly similar. All the codes will remain the same. With that being said, I think I will pause this video now. I'll see you all in the next video. Till then, have a good day. Bye.